Hi, I am Inam. In this video lecture, we will be talking about moment of inertia. So the first question comes in mind that what is moment of inertia? Moment of inertia is the ability of a body to resist the bending along any possible axis. So we will calculate in this video lecture the moment of inertia for these two rectangles combinedly. So collectively we will calculate the moment of inertia. So for this we will calculate the central point of each rectangle. So by only dividing the each dimension by 2, we will get the CG of these two rectangles. CG means the where the total mass of the body acts, the point where the total mass of the body acts. This point is called center of gravity, which is symbolized by CG. So the first step is to calculate the central point of both rectangles by only dividing the each dimension by 2. So the center of gravity for the above green rectangle will be this point. The central point of this rectangle will be this. From this side to this side the distance is 2y2, because we will divide this 10 by 2, we will get 5 distance. Now from this side, from the center point to the lower fiber, this distance will be half of 4. So 4 divided by 2 will be 2 inches. So we had calculated the center of gravity of first green rectangle, which is along y-axis is 5 and along x-axis is 5 and along y-axis is 2. So we will interested the along y-axis dimension, because only the along y-axis dimension are used to calculate the combined center of gravity for both figures. For moment of inertia, we will require the axis to axis dimension, so which is along y-axis. Now we will calculate the CG of the below rectangle, which is this point. From bottom it will be from bottom to the center it will be 6 inches, because 12 divided by 2 will give us 6 inches. Now from x-axis it will be 3 inches. 6 divided by 2 will give us 3 inches. So we will only interested along y-axis dimension 6, and from this bottom fiber to the central point the distance is 2 inches. From this bottom to the center of this rectangle is 6 inches. So I only rewrite these dimensions. Now the second step is to calculate the combined center of gravity for both figures. Remember, this is the second step for calculating the moment of inertia. So for this the distance from lower fiber to this central point, the total distance is 12 plus 2 inches. It will give us 14 inches. This will be used in further calculation. And the distance from this bottom fiber to this center of the first rectangle is 6 inches. So these dimension will be used. So now the requirement will be to calculate the moment of inertia or the center of gravity for both combined figure. For combined figure we will calculate the center of gravity, means the y dimension where the total mass of both rectangle will act. So we will interested to calculate this y dimension. From this bottom, from reference axis, what will be the value of this y, where the total mass of both rectangle acts. So for calculating the center of gravity for a combined figure, for this the reference axis needed. So I referenced this bottom as a reference axis. So we will calculate the center of gravity for both figure from this central axis. Remember this. You can also calculate from the upper fiber as a reference, you take as also the upper fiber as a reference axis. Now in this question I have reference, this is a reference axis. For calculation of combined center of gravity, we will require to calculate the area for both triangle. So area of green triangle will be area of the below triangle will be, I mentioned subscript A1 for this figure 1, and this is the figure 2. So the area of A1 will be 6 times 12, so it will give us 72 inch square. This is the area of first rectangle. Now I will calculate the area 2 for green rectangle, which is 4 multiply 10, it will give us 40 inch square. It is the area of green rectangle. This is needed in calculation of central of gravity for combined figure. Now I will use the formula. This is, remember this, from the reference axis, the distance from the reference axis to the center of first rectangle is d1, and the distance from the reference axis to the center of second rectangle is d2. Here d1 is equal to 6 inches and d2 is equal to 14 inches. Now I will write the formula for the center of gravity from the reference axis for both combined figures. So the formula is y bar ry is equal to a1 into d1 plus a2 into d2 divided by a1 plus a2. This is the formula for the center of gravity for the combined figures. So here 2 rectangles are given, you will write only 2 areas. If there are 3 rectangles are given, then you should write 3 areas in the bottom and up with the perpendicular on d1, d2, d3. So now I will only just put the values for this respective values. For a1, which is 72, and d1 is 6 inches, a2 is 40 and d2 is 14 inches. I had only substitute the value of a1, d1, a2, d2 is 72, 6, 40, 12 respectively. So by calculation we will get y is equal to 8.9 inch from this bottom. Remember this, from this bottom the center of gravity is 8.9. This is the calculation for the center of gravity for both figures, which is 8.9 inches. Now for calculation of moment of inertia for each figure, we will use the parallel axis theorem. The formula for parallel axis theorem is this. For first figure, for the below rectangle, I1 is equal to bh cube divided by 12 plus ay square. A is the area of rectangle 1, y square is the from this center to the center of gravity of the overall figure. The center to the axis to axis distance is y. Remember this. This is the most important step for calculating the moment of inertia by using parallel axis theorem. This is the formula for parallel axis theorem: bh cube divided by 12 plus ay square. Here y is the axis to axis distance. This is the very crucial step for this question. So we will calculate this y distance. Y is from this reference axis. Y the center of this rectangle is 6 inches and the overall center of gravity is 8.9. So for y you will subtract 8.9, we will subtract 6 from 8.9, so it will be the center of gravity. It is the y distance, axis to axis distance, which will become equal to 2.9. It is very important step for this question. So we will just put B is 6 inches, H is 12 inches, the overall depth or height, divided by 12, plus A is the area, which is 6 multiplied 12 into y square. Y is 2.9 raised to the power 2. So by putting the values, instead of B 6 inches and H is 12 raised to the power 3 divided by 12, plus area of first figure is 6 into 12 into y is the axis to axis distance, which is 2.9 square. So the area moment of inertia of first figure will become I1 is equal to 1469.52 inch raised to the power 4. The unit of moment of inertia is unit raised to the power 4, which will be millimeter raised to the power 4, anything. So this is the moment of inertia for the first figure. Remember, this is the moment of inertia for only this figure from the reference or from the central of gravity of both figures. Now we will calculate the moment of inertia for the green figure. For the second figure, we will use the same formula, bh cube divided by 12 plus a2y square. Y is the axis to axis distance, the centroid of the green rectangle to the CG of both figure, means this axis, from this axis to this axis dimension is y. So in this case, y will be 14 minus 8.9. So this will be the value of y. So it will becomes 5.1. This is 14. From the reference axis, we will subtract this 8.9. We will get this distance. Remember this distance. So it will become 5.1. Now putting the values of B is 10 and H is 4 cube divided by 12 plus A is 4 into 10 into y is 5.1 square. When we do calculation, we will get the value of I2. So the moment of inertia for the second figures comes 1093.73 inch raised to the power 4. This is the moment of inertia for the second figure. For the overall moment of inertia for a combination of both figures, the moment of inertia will be I1 plus I2. This is when we consider this is a single figure, so the moment of inertia of each individual figure will be added. So we will add the moment of inertia for both rectangle. We will get the total moment of inertia. So the overall moment of inertia will be I is equal to I1 plus I2. By putting the value of I1, which is I is equal to, putting the value of I1 is, for I1 is 1459.52 and for I2 is 1093.73. By adding these two moment of inertia, we will get the total moment of inertia, which will be, so by adding I1 and I2, we will get the total moment of inertia, which is 2563.25 inch raised to the power 4. This is the whole procedure for calculating the moment of inertia, combined moment of inertia for both rectangles. So I only summarize these steps. The first step is to calculate the CG of each rectangle. The second step is to calculate the area, and in second step the sub step is to calculate the area, and the main step is to calculate the center of gravity for both figure. The point where the total mass of both figure acts. This is the center of gravity. In second step, we will calculate the center of gravity. In third step, we will calculate the moment of inertia for figure 1 and figure 2 by using the parallel axis theorem, by mentioning any axis as a reference axis and calculating the axis to axis dimension, which is represented by y. So by using the parallel axis formula, we will get the moment of inertia for figure 1 and figure 2. And the last step, by combined moment of inertia, we will just add the moment of inertia for each rectangle 1 and 2. We will get the total moment of inertia, which is the internal resistance, internal capacity, ability of a body to resist the bending. This is the whole procedure and concept behind the calculation of moment of inertia. Hope you get all and understand all. So take care of yourself. Allah Hafiz.